Quadratics unit, summative review. Okay, next objective is objective 2, and this is using the quadratic regression to find the equation given 3 or more points and also to make predictions using a quadratic model. So, we first want to write the quadratic equation containing the points -5, 14, 3, 110, and 19, 1454 in standard form. We're going to turn on our calculator, and we're going to go to Stat, Edit, and in list 1 we're going to put our x values. So -5, and then 3, and then 19. Then we're going to move over to the second list, and we're going to put the corresponding y values in. So 14 goes with -5, 110 goes with 3, and 1454 goes with 19. Since we're not being asked for any predictions, all I'm going to do here, let me get this, is press Stat. I'm going to go and Calculate, and then we're going to go down to Quadratic Regression and press Enter. Our x's are in list 1, our y's are in list 2, so we simply come down here and we calculate. 3, 18, and 29. So now our answer is y equals 3x squared plus 18x plus 29. That's it. There's really no work to be shown since you did it all in the calculator. The next problem. The turnstiles at the entrance to the home and garden show kept track of the number of people entering the fairgrounds. For the first 7 hours following the opening of the show, find the quadratic equation that models the data shown round to the nearest thousand. Now notice I don't care what the equation is. I care, find the quadratic equation, sorry, that models. I do care. Let's on to the next one already. So, here, I need to move this over here. This isn't behaving as well so that I can push my buttons. Okay, so now we're going to hit Stat. We're going to Edit. I need to clear my lists. Again, be sure you're clearing and not deleting. I go up and I hit Clear and I hit Enter and my lists are cleared. Here I've got hours 0 through 6. So 0, 1, 2, 3, 4, 5, and hour 6. And I'm going to come over here and I have 6.8, 5.92, 5.12, 4.98, 5.22, and 6.6, and finally 7.3. Okay, those are the first 7 hours, or first 6 hours, okay? Or in the first 7 hours, hours 0, 1, 2, 3, 4, 5, 6. To get the equation, Stat, Calculate. Again, I'm going to come down because we already told for the curve of best fit, quadratic. X's are in list 1, Y's are in list 2, and I calculate, and there's my answer. Let's pull this over here. Oops. And I'm going to round to the nearest thousand. So that means I have to go out 4 decimal places. So this is going to round to a 3, stay a 1, and round to a 9. So you should have y equals 0.233 x squared minus 1.291x plus 6.839. That's the equation. All right? So far, so good. This is just button pushing. The next one, a football coach records the height at every second a ball is punted in the air. Some of the data appears below. To the nearest foot, what is the height of the ball at 1.3 seconds? This is the one where I don't care about the actual equation. I just care about the data. So I'm going to go to Stat, Edit. I'm going to clear my lists. You should be good at this by now. And then I'm going to put in 0, 1, and 2. Then I'm going to come over here and I'm going to put in 2.5, 17.5, and then 0.5. Notice the ball is going up and then it's coming down. Now, I'm going to hit Stat, Calc, Quadratic Regression. X is in list 1, Y is in list 2. Because I'm going to make a prediction, I want to store my regression equation. So here I'm going to press the vars button, arrow over once to get y vars, and then I'm going to press enter to get the function and enter to get the y1. Now my equation will be stored in y1, so I don't have to write it down. I can just calculate. If I wanted to write it down, I could use my a, b, and c. But since I'm not being asked for that, I'm just being asked to the nearest foot, what is the height of the ball at 1.3 seconds? I can go, and I'm going to go to my table here, but I'm going to go up here to Window, and where it says Table Start, I want it to start at 1.3. That way I get it exact. Then second, Graph gives me my table. At 1.3, it's 15.76. So, 15.76 or 16 feet if I'm rounding it to the nearest foot. Okay? All right. Next up on this page, the height of a diver t seconds after jumping is modeled by this expression. When is the diver's height greater than 45 feet? For this, again, let's use your calculator. Except we're not doing a regression. Instead, I'm going to go to y equals. I'm going to clear what's there. I'm going to put this expression into the calculator. So negative 16x squared plus 6x plus 128. Now, I want to know when the diver's height is greater than 45 feet. So if I do a, remember this is going to make a parabola that opens down. So I'm going to do y is equal to 45. That's going to be a horizontal line. I want to know anytime this curve is above 45. Now I'm going to graph, but I need to look at my window. I'm not jumping negative 10 seconds, so I'm just going to make this negative 1. And then I'm pretty sure the diver is going to be on the ground by the time 8 seconds is over. Scale is at 1. The minimum y value, I don't care when he's below, so it's negative. I'll make it negative 10. And I'm going to go up to, well, this says 128. So I'm going to try first 150. I don't want to go by ones, that'd be too much. I'm going to make it go up by tens. And I'm going to enter. Now, I'm going to, so here we go. So now I'm going to graph now that I've set my window to something that seems normal. And see, I can see the top of the graph. I can see where it hits the ground. And here's my 45 line. So I can tell that as soon as the diver jumps, she's already 128 feet up off the ground. She jumps up, she comes down, 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 down. What I want to know is right here. How many seconds is that? Well, that's going to be the intersection between this curve and this line. So second, calc, and I can tell it, I want to find the intersection between these 2 points. So my first curve, I don't care, the second curve, I've only got 2 of them. And now my guess, I want this intersection. So I just hit enter. Hit enter. There we go. And here's the intersection at 2.4728. So when is the diver's height greater than 45 feet? From 0 to 2.47 seconds. That's the time period where the diver is above 45 feet. It's not bad, is it? Next one. Using the formula for the area of a circle to solve, to allow the proper flow of water, the opening of a circular pipe must have an area of this many square inches. Find the radius of the opening of the pipe. Use 3.14 for pi. Well, this is just solving an equation. Area is equal to pi r squared. Well, my area is 0.441562 and pi is 3.14 r squared. For this, again, your calculator is your friend. So you're going to do, got to quit out of this guy, 0.441562, and you're going to divide this by 3.14, and you get an answer. But that's what r squared is. So now second square root, and I'm going to get that answer back. So second answer, that'll pull that number in there, and I hit enter, and it's 0.375. So r is equal to 0.375 inches. That's all. It's just a straightforward area problem. The formula for finding the height of a rocket that is launched with a speed of 128 feet per second from a height of 96 feet is given here. Now, what is the maximum height of the rocket that the rocket reaches? That would be the y coordinate of the vertex. Well, so I take my calculator, I go to y equals, and I'm going to clear everything. And I'm going to put the equation in, negative 16x squared plus 128x plus 96. And now I want to graph it. So I'll graph it and see if it shows up. Oh, darn, I don't see the top of it. I don't see where it's hitting over here. That means my window needs to be bigger. Well, why don't I make it go to, say, 15? And the height of it. This is a rocket, so let's make it 250. And then I'm going to graph it. Oh, okay, now I can see it hitting. Still can't see the top. So again, I'm going to go to my window, and I'm just going to come down and say, how about if I make this 350? This time I'm going to go up by 20s or 25 so that I don't have so many little tick marks over here. And I graph it. And now I can kind of see the top. If you want to make sure that you see the top all the way, you can do something like 375. Press enter and then graph. That way you clearly see it clears the top. I want the y value of the vertex. So again, I can use my calculation here. I can either use negative b over 2a and then plug it in, or I can just graph it and do second calc. My vertex is going to be my maximum, and the calculator asks you left bound. So I have to move that little spidery guy, the cursor, to the left of the maximum. Press enter. Right bound. I have to move it to the right. And I press enter, and guess I just press enter again. It tells me at 3.999, so at about 4 seconds, it's 352 feet high. So at 4 seconds, rocket reaches max height of 352 feet. Boom. Now, how long approximately is the rocket in the air? Well, again, let's look at this. The rocket takes off at 0. It's in the air, in the air, in the air, in the air, in the air. Boom. Oh, it's that second x-intercept. That's where it's no longer in the air. Again, I can use my calc. Second calc, I want to find out the 0. because that's my x-intercepts. And it asks left bound. So I got to move my little cursor. I'm just going to move him a little bit closer so you can sort of see him. So here he is. He's in positive y's. Now right bound. I have to go until he's on the other side. And I notice that he's on the other side because that's a negative. Press enter. And I press enter again. And there it is. It's at 8.69. So rocket is in air for about 8.69 seconds. Okay, and if you kept rounding out, 6904, but 69 is to the nearest hundredth. All right, that's the last question in this part. If you have other questions or you don't understand part of it, please come in and ask.